In this video, we're going to look at the process of diffusion of gases. And this is essentially a process where molecules disperse in space in response to differences in their concentration within that particular space. And you can look at and calculate the rates of diffusion by looking at the amount of gas passing through an area divided by the unit of time. And some of the pieces of features that you're going to need to know about diffusion or terms is this thing called concentration gradient. And concentration gradient is where you look at over a particular distance the concentration of the molecules, and the gradient can go from high to low or low to high. The amount of surface area available for diffusion, this just means how much of the gas either you have or how much space it has to diffuse into, the distance it can travel, and another feature that affects the rate of diffusion is the mass of the molecule. Now, when it comes to diffusion of gases, the things that I'm going to ask you to be able to do are something kind of like this with this example problem. It says, which of the following gases diffuse more slowly than oxygen or O2? And really, you don't have any information about these gases other than their molecular mass or molar mass, which is one of the features that can affect the rate of diffusion. And so, as simply as this, the things that move slower than oxygen will be of a higher molar mass. And so what you would have to do is go through each one of these gases and calculate their molar mass. So F2 has a molar mass of 38.00, and all of these are the units of grams per mole. Neon is 20.18 grams per mole. N2O has 44.02 grams per mole. C2H2, or acetylene, is 26.04 grams per mole. NO, 30.01 grams per mole. Cl2, 70.90 grams per mole. And H2S is 34.08 grams per mole. Well, you need to compare each of those molar masses to oxygen's, which is 32.00 grams per mole. So in this question asking more slowly, which ones are the higher ones? So it turns out F2, N2O, Cl2, and H2S. Those are going to be the molecules that move slower than O2, and that would be our answer. Some of the other types of questions we could ask about something like this, what might be which ones go faster? In that case, you would do neon, acetylene, nitrogen monoxide. And you might want to, which one travels at the closest rate of O2? And you would look at something, which one has the closest value to 32? And that would be nitrogen monoxide. So there's all kinds of varieties you could ask about the rates of diffusions when it comes to gases, but essentially we're going to be using molar mass as a way to gauge that. Okay, this has been a video on diffusion of gases.